In this video, we're going to be continuing on with the regression series using TensorFlow. And as you recall from the last video, what we did is we went to this website here, which provided us with the UCI machine learning repository. One of the data sets found there was this auto MPG for miles per gallon. And it's just a data set that includes a number of criteria for a car, including miles per gallon, but also a number of other things like how many cylinders the car has, displacement, horsepower, how much it weighs, the year it was produced, where it was produced from, etc. So these are the features which we went ahead and stored in our Python file as a list. So each of these are the unique features of our data set. And the whole purpose of this series of videos is for us to make use of the technique of regression to try to figure out what miles per gallon a given car has based on these other features. So from this data set, we would like to build a model such that all of the other features will have some predictive power in determining what the miles per gallon for a given car is from a test data set that we have not seen before. So we read in that data set as a CSV file, specifying the heading names to be the column names or variable feature names. And then what we did is we just created a copy of that just because we're going to be modifying this. We're going to be cleaning it up, and that's indeed what we're going to be doing in this video to kind of prepare the data to be fed into a model. And then we just viewed the tail or the last part of that data set just to make sure that we read everything in properly and to take a very quick cursory glance at the data. So what we're going to be doing in this video is we're going to be continuing on with looking at that data set, so observing some properties and features of that data set, along with cleaning up some of the data as well and preparing it to be fed into our regression model. So that's what we're going to be doing in this video. And the first part, the cleaning of the data, is what we're going to start with. And what I'd like to start with is just to take a look at how many of these values for each of the variables that we have are missing. So the way that we can do that in Python is we can do something like dataset.isNA.sum. So this is going to sum for every single variable in our data set. It's going to sum any of the values of each of those respective features, and it's going to sum the ones that happen to be NA. So what we should get here is a table of all of our features and then a number specifying how many values are missing in each of those features. You can see I ran this before, and this is our output here. So we see that we don't have many missing values at all. In fact, this is probably relatively uncharacteristic to what you will encounter, let's say in the wild, when you're dealing with a data set that is not as nicely formatted as this one. This one's kind of a bit of an anomaly in terms of what you'll probably encounter in the real world. So the only thing that actually has missing values is this variable here, horsepower, and there's only 6 of them. So there's 6 missing values of the horsepower feature. So there's a number of ways that you can deal with missing data, and indeed that goes well beyond the scope of this video. There's things like imputation and it's really a whole field that's dedicated to figuring out what you do with values that are missing. So that way you can kind of not sacrifice the size of your data set by dropping a number of variables or values that happen to be missing. In this case, since we only have 6 and we're trying to keep things simple, our solution is just going to be to remove those missing values from our data set. So I'm just going to go ahead and do that. And the way I can do that is I can say dataset. So I'll redefine our dataset variable is equal to dataset.dropNA. So dropNA is a built-in function that is provided from the pandas library, since we're dealing with a pandas data frame, and it's just going to drop any of the values in this data set that are NA. So it'll drop those 6 horsepower values from our data set. So that's kind of the one thing that I wanted to do there. The other thing that I wanted to do is also try to structure the data in a way that would be easy or easier for us to feed to our model. One of the things that we need to do is take a look at some of these variables. One of the ones that I want to take a look at is this origin variable. So origin is a feature that in this case is a number between 1, 2, or 3. So it's 1, 2, or 3. And that is an encoded piece of information that specifies where the vehicle came from. So 1 in this case corresponds to the vehicle originating from the US, 2 from Europe, and 3 from Japan. So this is just a feature that has these numbers to encode that data. But for our model to work on this, we want to kind of structure this in a way that it's going to make the regression model kind of take this in and deal with this properly. If we just give it a discrete value like this, it's not going to know quite what to do with this. So what we're going to do is we're going to convert this variable into something known as a one-hot encoding. So one-hot encoding basically just means that if it's any of those three for a given car, if let's say the car was produced in the US, we'll have a vector of 3 entries, and the one corresponding to the US entry will be 1, and the rest, in this case Europe and Japan, are going to be 0. So for a car produced in the US, we'll have a vector that looks kind of like this. For a car that was produced in Europe, we would have a vector that looks like this. And the reason it's called a one-hot encoding is because the one value, in this case, of the feature that is actually activated or turned on is the one that has the value of a 1, and the rest are going to have the value of 0. So we're going to essentially modify this origin variable to have this one-hot encoding feature. And we can do that very easily in pandas. So what we're going to do is we're going to say origin is equal to dataset.pop origin. So what this is going to do is this is actually going to remove the origin feature from our data set, because we don't want to have this feature that has the numbers 1, 2, and 3. Instead, we're going to want to do this one-hot encoding thing. So what we're going to do now is we're going to create 3 new features in our data set. One is going to be dataset of USA. So this is if the vehicle originated from the USA. And what we want to do here is we want to say origin, I should spell it right, origin equal 1 times 1.0. So what this is doing is we've removed this origin feature from our data set, and we stored that vector in this variable called origin with lowercase o. And then what I'm doing is I'm creating a new feature in our data set with the name USA. And if that feature, if origin happens to be 1, so if, remember, 1 encodes the information that originated from the States, if that's 1, I want to multiply this by 1. So this is going to essentially put a 1 in the spot of where 1 is located in this vector. So it's essentially going to produce a vector that looks like this. Likewise, for the other elements of this data set, so I want to create 2 other features, one being Europe and the other being Japan. So for Europe, again, that information origin is a 2. That means it originated from Europe, and then 3 if it originated from Japan. So I'm going to add those 3 features. I remove the one that said origin that just had 1, 2, and 3. And then what I want to do is I just want to take a look at this data set and see what we're working with. So let's just go ahead and say print dataset.tail and see what we have. So this should print out something that looks somewhat familiar to what we saw in the first video, but now what we have are these 3 new features. So USA, Europe, and Japan. And you can notice that for this particular instance, this car, what we have here is this one was produced in the USA. We have a 1 here to indicate that that is the case. Obviously, you can't have it produced from multiple different places, at least not in this case. The other ones are going to be 0. For this other entry down here for this car, this one was produced in Europe, and that's indicated by this 1, etc., etc. So I hope the concept there is pretty clear as to what we're doing. So now that we've kind of modified this origin variable to have a one-hot encoding, what we're going to do is we're going to split our data set into a training set and a testing set. And this is pretty typical practice. You want to obscure some portion of the data from your model, so that way it's trained on a portion. And then that way, when the model is sufficiently trained, you want to feed it an element of a test set, which has been obscured from the model. And you want to ask it, hey, here's something you haven't seen before. How good are you at predicting, in this case, miles per gallon of a car? So we want to do that split here. So the way that we can do that in pandas is we can create 2 data sets. So one we'll call train set. So train data set is equal to dataset.sample. And what we're going to do here is we're going to specify what proportion of the data set we want to be contained in the train data set. Generally, you'll see something like 80% of the data used for training and then 20% of the data used for testing. This just, the more data that your model has to play with, the better it is at assessing and predicting things. So this is just a general rule of thumb when it comes to splitting, but you can go ahead and play around with this, and it's not really written in stone as to how you split your train and testing set. We're just going to stick with the convention here though. So what we can do here is we can specify what proportion of that data we want to split. In this case, we're going to say 0.8 for 80%. And then we can also specify a random state. Now, generally how this is done is this samples from the data set. It takes 80% of the data from this big data set that we have, and it takes 80% at random. So it randomly samples from this data set. Now, what we want to do for consistency to make sure that we get the same results every time is we can hard code a random state seed, which essentially says, okay, take 80% of the data, but don't randomize the sampling. Take the same sample from this train to create the training data set every single time. Again, this is just for consistency. In the wild, when you actually train your data, you probably don't want to have this random state equals 0. You want it to randomly sample from the data set. But again, for the purpose of this tutorial and for consistency, we're going to do that. The next thing is we're going to want to create our testing data set. So test data set is equal to dataset.drop, and then we'll go ahead and say train dataset.index. So what this is doing is it's saying, okay, from that data set, the big data set that we have, go ahead and drop any of the indices that correspond to the training set. So I'm essentially just removing all of the data from the big data set that is in the training set, and the remaining 20% that we have is now going to be stored in the test data set variable. So now what we can do is we can go ahead and just do some quick and dirty plotting and analysis and just kind of see what we're working with and what we can kind of get from a visual analysis of the data. So what we can do is we can use the Seabourn plotting library to take a look at some of these features. So what I'll do is I'll say sns.pairplot, and I'm going to give it the train data set, and I'm going to go ahead and give it a vector or a list of the features that I would like plotted. So I'll go ahead and say miles per gallon, let's do cylinders, let's do displacement, and let's do the weight as well. So weight with an uppercase W. And what I'm going to do is I'm going to specify that I want it to give me a diagonal graph of kind KDE. So this is an optional parameter that Seabourn allows you to specify. So then after I do this, I'm going to go ahead and say plt.show to make sure that we actually can visualize what this line is going to produce to us. So this is going to actually allow us to plot the data and see what we have. Let's go ahead and run this. We'll write it. We'll say Python part2.py. So it's going to go through the motions of everything that we have in the script, so it might take a little while. But here we see the plots that Seabourn generated for us. So let's just take a little time to take a look and see kind of what this plot is telling us. So on the axis here, we have miles per gallon, cylinders, displacement, and weight. And we have the same features on the x-axis here as well. So for instance, the diagonal in this case corresponds to plotting miles per gallon against miles per gallon. That's what this top left plot corresponds to. So this shows kind of the distribution of values in our data set for the miles per gallon feature. Likewise, this second diagonal plot here, this corresponds to the distribution of the number of cylinders. So that shows how that looks, and then also for displacement and for weight. Now the other plots in this case correspond to how these variables compare to each other. So for instance, let's take a look at this plot here. So this plot is plotting weight against miles per gallon. And you can see that you have this kind of curve that's going down, and that is indicating that as miles per gallon goes up, the weight tends to go down. So that kind of makes sense that the more efficient cars, smaller they are, they probably have better, miles per gallon, things like that. So that's a similar type of analysis can be taken away from looking at any of these other plots. So for instance, this one is plotting miles per gallon against displacement, kind of a similar story here. The higher the miles per gallon, the lower the displacement, and etc. So you can kind of get a general view of the data by just kind of plotting something like this that gives you a lot of information visually, some of it more helpful than others. And this can be very insightful when you're trying to assess the features in your data set, the data in the data set, and also try to kind of think through how you would structure a model and what you might do to increase the number of features or what have you. So this is just one visual way of kind of looking at that data, which is quite nice. So I'll just close that and let's go back to the code. So now that we've plotted that, let's go ahead and just, we can also take a look at something a little bit less visual, which is just the overall statistics of the data set. So this is just going to be making use of the describe feature that Pandas provides. It just gives a number of basic statistical features of the values or the variables. So for instance, things like the mean, standard deviation, the minimum value, the maximum value. So let's just go ahead and take a look at what that looks like. We'll create a table that kind of shows all of these things. So I'm going to say train stats. I'm going to create a new variable, which is going to be equal to train dataset.describe. So what I'm doing here is I'm just making use of that built-in describe method in Pandas, and I'm just storing the result of that applied to the training data set into this train stats variable. The next thing I want to do, since we're trying to predict the miles per gallon feature, I'm just going to remove this from the data set, from the statistics, just because we're trying to predict this thing and we want to look at the other features in our data set. So I'm just going to say train stats.pop. And again, this removes this from the data set, miles per gallon. The other thing I want to do is I'm just going to transpose this so that way the rows, essentially the matrix just becomes transposed, the matrix being the statistics. So I'm just going to go say train stats is equal to train stats dot transpose. This isn't necessary, but this just makes it a little bit better to look at. So that way the features are going to be on the left, and then the statistical measures like the mean and the standard deviation are going to be the headings of this thing that we're going to be printing out. If you don't do that, it'll just be the other way around, but I think it's a little bit easier to look at using this transpose. And then let's just go ahead and print the train stats variable. So we'll go ahead and do that. And what we should see is just kind of a table similar to what we've seen before, which just kind of gives us, again, here on the left side, the features, and then a number of statistical measures that might be useful for us that are just kind of high level, that, again, in the same way that those plots gave us a nice visual representation of the data, this gives us a more textual but also somewhat visual representation of what we're looking at. So for instance, this shows how many total variables, how many total values there are for each variable, what the mean is for each variable. So the cylinders have an average of 5.477, the standard deviation, what's the min value for cylinders, what's the max value, and so on. So this just kind of provides a nice, concise table of information that kind of gives you, a little bit more information about the data set that you're working with. The thing that I want to do here is I want to go ahead and normalize the data set. And essentially what we're going to be doing for the normalization or standardization in this case is we're going to calculate a function that's going to tell us how many standard deviations from the mean a given value happens to be for our data set. And what we're going to use for that metric is this z-score standardization. So if you are unfamiliar with this metric and how it's used, kind of the synopsis of what I just said is kind of the soundbite of what that is going to tell us, the information that's going to tell us in this case. But if you read the Wikipedia article on z-score normalization, standardization, you can get a little bit more information as to how this is used and much more information about kind of the general principles on which this is based that probably go beyond the scope of this video. So we're just going to use this, kind of the reason why we're going to use this is because instead of feeding in training data that is in these units, that's arbitrary units, this makes it hard for the model to know how best to utilize the data that it's given. So the normalization factor here is going to allow us to kind of make the resulting model dependent or less dependent on the choice of the units used in the input data set. So this is going to kind of strip that away and allow the model to kind of take advantage of the brass tacks of the data and not be subject to the units that are used. Again, if you want more information on z-score standardization, I'll leave a link to that in the description of this video and you can check that out. So what I'm going to do is I'm just going to go ahead and implement that formula, which is very simple. So I'm going to call this function, let's just call it normalize, and it's going to take in a data set x. And all I'm going to do here is I'm just going to return x over, or I should say minus, the mean of the data set or the stats. So train stats of the mean. And this is going to be divided by the train stats of the standard deviation. So if you look at the Wikipedia article for z-score standardization, you'll see this formula here. I notice I'm missing an underscore. And that's all I'm doing here is I'm just very simply implementing that function, and then we'll create normed versions of our train and testing data sets that make use of this function. So let's go ahead and do that. So I'll call this normed train data is equal to normalize, we'll say train data set, and then we'll do the same thing for test as well. So this is going to be not train but test, and this is also going to be not train but test. So what we did there is we went ahead and created these normed versions of our data set, which again is going to make it easier for the model to be able to take advantage of that data. And that, I think, will pretty much do it for this video. We've kind of prepared the data in a way that I think we can construct a simple regression model, and hopefully that model will have some relatively good, decent predictive power. And that's what we're going to investigate in the next video. So we're going to see how we can make use of TensorFlow to build a regression model based on the data that we have manipulated thus far. So thanks again for watching, and I'll see you in the next video.